Hey, what's up, guys? Chung here. And so today, let's continue on our LeetCode problem solving journey here. And so today, let's take a look at this problem number 689. Maximum sum of three non-overlapping subarrays. Okay, so basically you're given like a array here, and you need to find out three non-overlapping subarrays whose sum is max. For example, this one, like the maximum subarray is, oh, and if there's like a same, if the result is the same for specific array, so for example, this 1 2 and 2 1, the sum is like they're both 3, and you need to get an answer, return the lexicographically smallest one, because if you choose, like, for example, this is the, okay, oh, by the way, and the output is the starting index of those three subarrays. And in this case, it's going to be 0, uh, 3, uh, 3, and 5, and 5. Basically, that's the maximum amount. And in case of this one here, you can either choose 0, 1, 2, or 2, 1, right? But 0, 3, 1 is lexicographically smaller than 1, 3, 5. That's why we return 0, 3, 0, 3, 5. Okay, so it's I think it's we can use a sliding windows techniques because let's, for example, let's think about this way, right? For example, let's we have instead for example, we have this method here, right? We have this like array here, and let's assume instead of 3, because 3 is kind of like annoying, right? What if we the what if there's only one subarray, right, with the length of k? Then what's going to be the maximum value for that, right? So what do? We simply just uh, we just scan through this array here, right? And let's say, for example, the subarray, the length is 2, right? And what do? We just keep like a sum of this length 2 subarray at right, and then we just keep scanning through the whole array, and then meanwhile we're keeping the we're keeping that we're keeping the maximum value, current values, and the start index, right, of that, right? For example, here, uh, 1, 2, right, is 3, right? Is 3. Okay, then the maximum value is 3. The starting index 0, right? And then we move one like forward. Now now it's at this position, right? Okay, I'll go. Now it's between 2 and 1, right? So the sum is for 2 and 1 is still 3, right? So how can we get the sum of this like length of k? So we already have the starting point. So in order to get the new sum of the subarray, we just remove the previously we remove the value just got fall out of this range, and then we just and also we add this the new element to our sums, right? So 3 is not greater than our max values, so we just keep moving. Now, how about here? Also 3, right? 2, 1 is also 3, so no, keep going. Now 8, right? So we see 8, okay, 8 is greater than 8, then 3, so we just update this one to 8. Then we also update our current index of this thing, which is 3, right? We keep going. How about here? How about here? 13, right? 13 is greater than our current max values, and we update this one to 4. and keep going. How about now? 12, right? Not skip, 6, skip, right? So in the end, we'll just have like 13 and 4, and the 4 will be the final result, right? And now we can expand this thing like to to two non-overlapping subarrays, right? So what does this mean? It means that we're gonna have like some two subarrays, right? Which at the beginning next to each other, right? Because that's why we are making sure it's a it's a non-overlapping subarrays, right? And then same thing, and then basically we're gonna be maintaining two set of value here. First one is the first one is the one the one subarray, right? And the second one is the sum of the two subarrays, right? And then every time when we see the and when we update the maximum value, like for two subarrays, right? And then index list, basically, right? And every time for the every time we see the first array, we just do the same as if it's only have one array. And when it comes to the second array, instead of so how can we check when is the time to update this maximum two subarray, right? Basically, every time when we get the current value for the second subarray, we need to we use this value plus the one subarray's max result, and then we compare with this maximum two subarray. Right, that's how we do the comparison. And if it's greater, then we update this linked list with the with this like the first subarray's max index plus the second plus our current index, right? And so on and so forth. And actually for the three uh, for the subarrays, the same thing, right? Basically, we're gonna have a uh, three variables, three set of variables to maintain uh, two sub maximum value of the two subarrays and the maximum value of three subarrays, right? And in the while we're scanning through it, we also maintaining the each maintaining the each subarrays like two subarrays total maximum and the three subarrays maximum total, also along with their set of the starting point relates to that total sum. And in the end, we simply return this uh, we simply return this three subarrays index list. Yeah, actually, this thing can be sorry, this thing can be extended to case case overlapping subarrays, but I think for now, just to make it a bit easier, I'll just use this three set of variables to help us calculate this problem. So basically, it's like three sliding window, right? Okay, so let's get started, right? Like I said, so we need a like bunch of variables to store those related informations for one subarray, two subarray, and three subarray, right? Okay, so first is the position, right? Is a position of that. Is the position of the one subarray, two subarray, and three subarrays, right? So we're gonna have the mm, best one index. How about this? And best two index and best three index. Okay. So the best one index obviously is a 0, right? How about the 2? The 2 is 0 plus 0 and k, right? Because at the beginnings, each of the subarrays they're next to each other, right? That's why we start from. How about 3? 0, k, and k times 2, right? Basically, that's our starting point for those three set of subarrays, right? And then we also need the maximum sum, right? The maximum one sum, right? It's what's the one sum? Which only one sum, right? Only one subarray. So in this case, it's gonna be 2k sum nums, right? Nums 2k. That's the first subarrays. How about the second subarray? So for the second subarray, so here we are maintaining uh, the the total sum, right? The sum of the two subarrays, not only the sum for the second subarrays, but the maximum sum for the total one and two subarrays. So here gonna be k times two, right? Same thing for the max three sum, right? So here it's gonna be the max sum times three, right? That's our initial that's our current the maximum, and then we also need like we also need our current one sum, right? Current one sum, and this current one sum is actually the the current sum in the sliding window of the current of the of a current array to maximum three. Yeah, because at the be sorry, no, not this one. The uh so here it's gonna be k, right? K to k, right? So this is sorry. So this one is the current the sum for the specific array subarray, not the total. You can call it total, right? Okay, all right, and right. So and then since we have those kind of like variables defined, we can start moving the sliding windows, right? Those three sliding windows. So for I in range, let me define like n equals to length of the nums here, right? For I in range, since we already initialized all the three subarrays, we should start from one here instead of zero, because for zero we already have the result here, right? We already have the result, and so that's why we need to start from one. And how about our ending point, right? So the ending point is we need to make sure we have at least enough spaces for all the three subarrays, right? So it's going to be n minus what? K times 3 plus plus 1. Yeah, plus 1. That's how we finish our ending point, because this is the range that we can at least to store all the to at least have the space for all the subarrays. Basically, we move all the subarrays to the end of the of the uh, of the array. So now every time, right? Every time we need to update our sum here, right? So let's do our update here. So like I said, in order to update these things, first we'll be removing the ones, removing this like value, the numbers out of the outside of the got got moved out of the sliding window, and then add the current one into the sum, right? Then what's the one just got removed? It's the for this one is the nums I minus one, right? For the one subarray, it's one minus one. And how about the one? Which one just got moved in? It's the I plus k minus one, right? So this is the one that's got moved in. How about the two sum, right? Similar, right? Uh, for the two sums, the one just got moved out is the I plus k minus one, right? And the one just got moved in is like I plus k times 2 minus 1, right? Same thing for 3. Uh, nums like I k times 2 minus 1 and nums I k times 3 minus 1, right? So then let's do once we have the new updated rolling sum for each sub windows, we just do a check, right? So if current one sum, right, is greater than the maximum one total sum, right, then we simply update the best one index, right, to what? To the current index, right? And then also the sum, the maximum one total sum equals to current one sum, right? And then the second one, if the current two sum is greater, so like I said, the current two sum, right? Current two plus, right? Like I said, it's going to be the maximum one total sum greater than the maximum two total sum, right? That's how we check because we want to know if the current one uh, plus the previously plus the current maximum one total sum can give us a better result in terms of the two subarrays, right? If it can, then we just update this thing to best two indexes to what? We just simply do I plus uh, I plus k, I plus k. That's the starting point. Yeah. And then here to, okay. Similar for the 3 here. Current 3 maximum. In this case, we're going to add 2, right? Uh, okay. So maximum 3 total. So in the end, we simply return the maximum 3 uh, indexes, which is the result we need. Okay, I think this this should work. Let's just run it. Oops. Seems like we made a mistake somewhere. Let's see. Uh, I think here. Yeah. All right. So a few things here. So why we're like maintaining this number, the the total arrays of this instead of a separate best index of 1, 2, and 3, right? Why we're maintaining the result instead of like a separate index? In the end, we just return the array consists of this 1, 2, and 3, right? Why can't we do that? Because because what? Because the when we calculate the third subarray windows, the second one. Okay, so the second one may got the second one, the second arrays might got updated, right? Because in this case, let's say once we move this subarrays to here, right? To here and the 6, 7, that's where the second subarray is, right? And then we see, okay, the second subarray, oh, we got a better result for the second subarrays window, right? And then here, basically, this best two indexes will be updated with this index 0, 1, 2, 3, 4, with 4 as a subarray index, right? If we do that, right, so the best two indexes will become 4, right? But is this the but will this one give us a better result? No, right? Because even though let's say we have a better two subarrays, but when we calculate the three subarrays, we see okay, we will not get a, a bigger value for the three subarrays. That's why we will not change the result for the three subarray index, which is still 0, 3, and 5, right? But if we don't save the history result like this, and we only save the latest single index for the 1, 2, and 3, then in the end we'll be having like 0, 4, and the 5, something like this, right? Because at this moment, the two subarrays index had already been updated from 3 to 4. But 4 is not the ones we need because we know because with subarrays starting at index 4, we will not get a better result, right? So that's why we are restoring this like history. Every time we are sure we have a better result, we just store everything, all the indexes at this moment to this variables here. And in the end, we just simply return this. Uh, cool. I think that's it for this problem. It's just like you need to like expand this sliding windows from 1 to 2 and even to 3. Yeah, I think that's the little trick here. And while you're expanding those three sliding windows, you need to maintain each sliding window's current values, and then you need to compare, will this will the current sliding window give me a better result? If it is, we update those three sets of variables, right? And then in the end, we just return this. Okay, cool guys. I think that's it for this problem. Yeah. Thank you so much for watching the video. Okay, see you guys soon. Bye bye.